Welcome back to this class. Let's consider this physics question. In a DC circuit, a 10 microfarad capacitor is placed in series with a 10 ohm resistor. The total resistance of the combination is dash. So we have our options there. So this question wants to test your understanding of the behavior of a circuit that contains a resistor and also a capacitor. So, and if the circuit is a DC circuit, such DC circuit is called RC DC circuit. So that is a DC, a direct current circuit that contains a resistor and a capacitor. Now, let me make a small drawing of that and then explain what will be the answer. So let's say this is the source of EMF. So this is the source of EMF, the cell, and is connected to the, let's have our resistor, and also we should have our capacitor. So this is the symbol for capacitor. So the two terminals must be equal. It's different from a cell. The two terminals of a cell, one is longer and the other is shorter. This is the positive terminal, which is always at higher potential. And this is the negative terminal, which is having lower potential. So, but for a capacitor, the two terminals are always the same because it's a parallel plate capacitor. Now, this is a resistor of 10 ohms, and this is a capacitor of 10 microfarad. Now, for two things can happen here. First of all, we can have an initial stage, then we can have a steady stage. At the initial stage, when we just connect this circuit, if you close the circuit, current will start flowing from the source of EMF, current will flow. The current will flow through the tube without any notice in this place, without any much problem. The current will be flowing because this capacitor is not yet charged. So that means the amount of current it can take will be zero over there. So it means the total EMF that is passing through will still, the total EMF of the cell will still be bigger than the EMF that each one of them will take. So in that regard, the same current will flow through them. The same current will flow when this capacitor is not yet charged. So that's the initial stage. But the steady stage where this capacitor is already being charged, or when it is fully charged. So in that case, there will be a problem. So, both the capacitor and the resistor, what they do is that they offer some opposition to the flow of current. They are the one disturbing current from flowing very well. So what capacitor and the resistor do, they offer some opposition. When something is supposed to be flowing freely, with the presence of these two, they will be opposing the flow of the current. Yeah, they will be opposing the flow of the current, especially now that they are connected in series. So they will be opposing the flow of the current. Now, immediately when this capacitor is fully charged, when it is charged, the opposition will be infinite. This one will have the greatest opposition. In fact, the opposition cannot even be measured. So, in that regard, the capacitor will serve as a circuit breaker. It will open the circuit. So, it means the opposition that this is taking will be infinite. So that means if you want to calculate the total resistance of this circuit, you add the, since they are in series, add the resistance of the resistor plus the resistance of the capacitor. We add both of them together. Since this one is infinite, and this remains 10 ohms. So our final answer for the total resistance is going to be infinite. But if you add 10 to infinity, the result will be infinity. So that means in this type of circuit, the opposition will be infinite at the steady state. But looking at this now, that the capacitor has 10 microfarad, it's already at the steady state because it has been connected for a long time. Because if it is not that, that means the capacitance will be 0. Since it has been charged to 10 microfarad, that means it has been connected for a long time and it is at a steady state like that. So in that regard, the opposition will be infinite. Thank you. God bless you.